Yeah, okay. So now, whatever for the transmission lines, what are the exact one? Okay, so that means what are the materials we are using, what type of conductors we are using means that is ACSR type of conductors. Okay, so ACSR type of conductors we are using for the transmission lines. And anyway, we will understand about, okay, so how ACSR conductors only we are using. Okay, so ACSR conductors only why we are using. Okay, so if you have any doubts, you can just if audio is not clear or otherwise you cannot see something on board, you can just message in the chat box. Okay, so there is no problem, I will be continuously monitoring this. Okay, so anyway, you will understand in this session, you will be knowing about how we are going to use these ACSR conductors. Why only ACSR type of conductors we are using in the transmission lines. Okay, so understand. So there are different types of conductors. Okay, you can see on board. So there are solid conductor system, bundled conductor system, stranded conductor system, composite stranded conductor system, and hollow conductor system. These are all the types we have. And anyway, what is the exact one? Okay, so everyone, okay, so just follow this one, whatever, however we are studying this. Okay, you just understand properly, you will get a clear idea about how to read the complete power system. Okay, in this session I will be giving about how you need to prepare for power system. Okay, so how you need to prepare for power system. Generally, what are the major subjects we have? We have power systems. If you are electrical engineer, you may know already these points. Okay, so everywhere these things they will be telling you. Okay, so one is our power system, second one is machines, okay, electrical machines, third one is electrical circuits, otherwise you may call as networks, and other one is electrical and electronic measurements. Okay, so these subjects are very major syllabus. Okay, so these four subjects, in these things also, if you take machines and power systems, okay, so these concepts are very huge. Okay, so there are many concepts we have. Once you study in order, then only you will be answering properly. Like directly you may know this bit, what are the conductor types we are using for the transmission lines. ACSR only you may answer, but to take ACSR type of conductor, what are the different types of conductors we are just testing before that. Okay, we will see why only ACSR type of conductors. Okay, so that we will be understanding, and in this session I will be giving about some more points about how to prepare for power system. Okay, so I will give about those things also. Okay, so anyway, we will just see. So I will give you, so there are circular type of conductor and there are square type of conductor. Which one we are using means we are using circular type of conductor. Why means if we use this square type of conductor at the on the surface at the uneven points, okay, just see direction of the surface, it will be changed here. So definitely the flux distribution is not same. Okay, so this effect is called fringing effect. Okay, fringing effect, no much information we can get here now, fringing effect only. Okay, so because of this, the voltage stress on the surface whenever the conductor is our this type, okay, irregularity points, these are called irregularity points. Whenever you use like this, definitely voltage stress on the conductor surface, it will be more. That's why what you have to do is you should avoid these irregularity points, this one like that. Okay, whenever it will be like that, the electrical corona loss on the surface of the conductor, it will be more. Okay, so whenever corona loss will be more, then our power transmission power, okay, so whatever transmitting we are from sending end to receiving end, it is not perfect. Okay, so that's why we have to use a circular type of conductor. Okay, so circular type of conductors we are just preferring. Okay, shape, if you ask the shape of the power transmission line, you can observe we are using circular type of conductors only. Okay, so now we will take this circular type of conductor and what is the perfect material for this. Okay, so that's what you need to understand. Okay, so for the conductor, this is a power conductor. Okay, so this is power conductor. So for the power conductor, so what is the material we are using? What are the possible materials? Okay, so you may understand conducting materials only we have to use. Okay, what are those materials? Okay, so if you have any idea, you can answer in this. Okay, there is no problem. If you know this concept before also, there is no problem. Just understand once, you will get some extra points definitely. Okay, so anyway, you see material, what material we are using means for this conductor we can use aluminum conductors, copper material we can use, or gold material we can use. Okay, Au means Rm. Okay, so that is gold, and similarly silver we can use. Okay, if you want you can give. So this is aluminum, you may know. So this is copper and this is gold. Okay, so gold material, and this is nothing but silver. Okay, these are all the proper materials we can use for the power transmission lines. Okay, for the power transmission lines we can use this. Okay, so and understand, whenever if you use the silver material for this, if you use the silver material, silver generally high cost, you can know, right? Silver is high cost we have. Whenever it is high cost, will you prefer for the transmission lines? We will not prefer. Okay, silver, if you use the silver, it's not at all economical for us. Okay, so that's why this thing we should not use silver material. Okay, and similarly gold, why we are not using gold? We are using the gold material for some other purposes. Okay, especially in India, gold material why we are using for the preparation of some ornaments. Okay, otherwise it is a prestigious for us. Okay, gold material is very prestigious for us, that's why we won't use for the transmission lines. Okay, it's not like it's costlier. Okay, it's costlier only, but the reason is we are using for the other purposes and it is very precious for us, that's why we are not using for the transmission lines. Otherwise these are very good conductors, silver and gold, these are good conductors. Okay, so and we have eliminated these two options for the transmission lines. Okay, and what are the remaining options we have? That is aluminum and copper. Aluminum and copper, these are the two things we have. So if you observe, okay, so aluminum and copper, what will be the preferred one for us? First we need to understand that. Okay, so aluminum and copper, if you take these two, so aluminum will be preferred. Aluminum will be preferred one. Why aluminum is preferred means there are some advantages we will be getting. Okay, so whenever you use aluminum, so there will be resistivity of aluminum is greater when compared to this copper conductor. So there are some advantages we are getting. Resistivity, okay, whenever resistivity is more, losses will be more. To decrease that losses, we will not use bigger conductor. Okay, like thickness of the conductor, we will make it like smaller thickness. Okay, if you use the aluminum conductor, so this will be aluminum and this will be copper. Okay, so whenever you use aluminum conductor, for the same amount of losses, if 200 watts of loss will be there, 200 watts of loss will be there, size of aluminum will be like this, size of copper will be like this. What you will be preferring means, you will prefer aluminum material only. Why means the material, okay, so how much amount we need for the making of transmission lines, it is less for aluminum conductors. Okay, so it is less for aluminum conductor. Okay, understood, right? Whenever it is less, then definitely we will prefer aluminum conductors only. Got it, right? That's why aluminum conductors we are using for the transmission lines. Okay, so this is the main advantage, and there are some other advantages also. Like whenever you use this aluminum conductor, as material requirement is less, so sag in the transmission lines. Okay, if we use the copper conductor between the two poles, if you use the copper conductor, so sag will be like this. Okay, so this much of sag will be there. If this is the actual part, sag will be this much, and if you use the aluminum conductor, sag will be little bit lesser. Okay, so compared to our copper conductor, aluminum conductor sag will be lesser. Okay, we can understand like that. Okay, so sag will be reduced. What are the advantages of aluminum we are using for the our transmission lines means, it is sag will be decreased, material will be decreased, material amount. Okay, so that means less material required. Okay, and similarly, so high power transmission is also possible using that. Okay, and there are some other advantages, now you will not understand. Okay, so once we go through the some other concepts, then you can get the points properly. Okay, so these are some of the advantages we'll be having. Okay, you can see, so material only we have just discussed. Okay, so material only we have just discussed, and what are the types of conductors we have. Okay, for the transmission lines, what are the types of conductors means the solid conductors we can use. So that means the solid, a single strand. Okay, solid conductor, otherwise we can call as a single strand conductor. Okay, single strand conductor. Okay, we can call like that. So that means a single strand will be there. Okay, and next we have stranded conductor system. Next we have composite stranded conductor, bundled conductor system, and similarly halo conductors. Okay, so these are all the different types we have. One by one you will be knowing now. Okay, so one by one we will be understanding. Okay, so first one is the solid conductor system. Okay, solid conductor system means, so let's give the diagram again. Solid conductor system and understand about, so why we are using solid conductor or why we are not using solid conductor. Okay, solid conductor system means a single strand conductor it will be. So where generally the radius will be r. Okay, so let's take the radius will be r. So this is solid conductor. Okay, so this is solid conductor. So current distribution in the solid conductor system. Okay, so we need to understand that current distribution means how the current flow will be there. Okay, our flux distribution also we can understand. If this is the solid conductor, then how will be the current flow in this means at the middle there will not be any current flow generally. Why means because of some effect. Okay, so all the current will be flowing near to the surface. Okay, so what is that effect? What is that effect? So you may know this point already. Okay, so all the current will be flowing near to the surface of the conductor. So what is that effect is called? Okay, so that's what you need to know. So that is nothing but skin effect. Okay, so you can know that. Okay, so this is skin depth, how much depth only we are getting the current flow, that is skin depth. Okay, so how it is gonna happen? Okay, that means it is a tendency of AC current flow. Okay, so it is the tendency of AC current flow that will flow in the conductor which is near to the surface. Okay, so near to the surface of the conductor, inside there will not be any current flow. Okay, that means inner, wherever inside resistance it will be, so it will not allow any current. Okay, so if you take the entire conductor, okay, entire radius we are not getting the entire radius, we are not getting the current flow, only near to the skin. Okay, so this is nothing but our skin effect it will be called. Okay, so anyway I will give you the definition. Okay, so this is just solid conductor system only. So let's take the definition of this. Okay, so then you can understand some points. Okay, so let's take this. So as what is the skin effect means, it is a tendency of AC current to be, okay, you can see, to be concentrated only on the skin or surface of the conductor. Okay, so let's take this again. So if this is the conductor, the current flow will be near to the skin or surface we can call. Okay, so that is nothing but skin effect. Okay, so for which it will be possible, for AC or for DC? Only for AC it is just possible. Okay, so not for the DC. Only for AC it will be possible, not for the DC. Understood, right? So this is only for AC. Skin effect is present in only AC. You can just represent here. Okay, so it is the tendency of AC current to be concentrated near to the surface of the conductor. Okay, so otherwise on the skin of the conductor we can call. Okay, if you see comparison between AC and DC transmission. Okay, so if you take DC current, okay, so same area of cross section for both the conductors. Okay, and this is AC and this is DC for example. Okay, so current in this one is AC and current in this one is DC. Okay, we will just compare the resistances. Okay, so AC resistance, how will be the current distribution in this means, in AC if the entire radius is R, okay, so entire radius you will not be getting the any current flow, but only near to the surface you will be getting. Okay, so that's what we just understood because of the skin effect. Okay, skin effect. But in DC there is no AC current, right? Because of the frequency change it is just happening here. Okay, but in DC it's not going to happen. Okay, so that's why for the entire radius, for the entire area of cross section you will be getting the current flow like this. Okay, so there is no space in between. Okay, so entire radius you can be getting. Okay, so area of cross section, if you just check. Okay, so for the entire radius you will be get here for DC current flow. For AC current flow you will not get like that. Okay, so let's take resistance of AC. So resistance of AC conductor. Okay, AC current flowing conductor resistance we are just checking. Okay, so whenever you check the resistance of this, so what is the formula for resistance? Rho, that is nothing but resistivity of the conductor, L, which is length of the conductor, and area of cross section where the current flow will be there. Okay, so if you take this is the conductor, perpendicular to the conductor. Okay, so if you see from this side, okay, whatever you are seeing, that is the area of cross section. Okay, so generally this area means area of cross section of conductor perpendicular to its length. Okay, so this is the length and perpendicular to its length we have to see. That means if you cut this, whatever you see like this, okay, that's what the area of cross section. Understood, right? So and similarly for this also the same. Okay, so RDC we will be calculating. RDC equal to resistivity of conductor into L, length of the conductor, divided by area of cross section. Okay, but you observe in these two formulas area is different. Okay, so area is different. That means area, this is AC conductor area and this is nothing but DC conductor area. Okay, so this is nothing but DC conductor area. Let's take like this. Okay, so can you observe for the entire area we are not getting the current flow, but here for DC, for entire area you will be getting the current flow. Understanding, right? So that means let's take this area. Okay, so generally both physical whatever area is there, physical area, it will be same. Okay, but for the appearing area wherever current concentrating, that area it is not same. Okay, so we can understand like that. You got it, right? So current wherever it is flowing, that is not same in both. Okay, so if you observe area of cross section of AC, okay, so AC for the entire area you will not be getting. Okay, so for the entire area you will not be getting, and only for this one. Okay, so area of DC if you just check, so that is for the entire area. Now you can get one point, area of cross section of AC is definitely less than area of cross section of DC, like that. Okay, so that means you can observe. Okay, so area of cross section of AC, so this all area, remaining area in the middle, it is not at all getting. Okay, so that's how you can get. Okay, area of cross section of DC, it is even more. Okay, you can get that. So that means if area of cross section it is changing, and we need to check resistivity of the conductor also, whether it is same or different. So this is aluminum conductor only, this is also aluminum conductor only. Whenever these two are aluminum conductors, so definitely you can get one point. So resistivity of DC conductor or resistivity of AC conductor, it will be same. There is no difference. And similarly, transmission line where you are giving between some sending end to the receiving end. Okay, so whenever sending end to receiving end, transmission line is present, so length will not be changed, right? If it is DC or AC, length it will not be changed. Whenever length is not changing, so rho value is same and L value is same, and R is inversely proportional to the area. Whenever R is inversely proportional to area, we can get one point. So if area is more, resistance is less. If area is less, resistance is more. Okay, inversely proportional, right? Now area of cross section of AC is less, when compared to area of cross section of DC. That's why resistance of AC, it will be more when compared to resistance of DC. That's why AC resistance, AC conductor resistance, it will be more for the, so for like this, okay. So AC resistance, AC conductor resistance, it will be more when you compare with DC conductor resistance, okay. So whenever resistance will be more, then I square R loss, that means power loss you will be knowing, okay. Generally power loss, how you can give? I square into R you can give. So now you can get one point. In AC resistance is more, that means power loss in AC, it will be more power loss in DC, okay. So like that some points we can get, okay, but we will not use DC transmission, okay. There are many other advantages we will be getting for AC, okay. So there are very huge advantages and easy access also possible for AC systems. That's why we will not use the DC transmission. Understood, right? So I will tell you at that time, okay. So whenever it's required, at that time I will give about why DC transmission we are not using, why it is not economical, okay. So we will be understanding later. If for the AC, okay, otherwise one point I will give now. If it is AC transmission, we have two different transmissions, okay. So like single phase we have and three phase we have. So in these two we can prefer three phase or single phase, there is no problem. And generally what we are using means, so from the sending end to the receiving end, if it is a transmission system, we are using three phase transmission only. So there are huge power transfer possible, okay. At a time we can transfer more power at a time, okay. So that's why three phase transmission we are just preferring here, okay. So that's how we can understand, okay. So this is a three phase transmission. Got it, right? So generally we are using three phase transmission. Single phase we won't see anywhere, okay. So only in the distribution system we have single phase distribution, okay, and three phase distribution system is also present there, okay. DC transmission we are not preferring, but whenever voltage is very high, if the length of the transmission line, that means from the sending end to the receiving end, if the length of the transmission line is greater than 500 kilometers, then only we will prefer HVDC, otherwise HVAC only we will prefer. Understood, right? So that is general analysis. But you see, one of the disadvantages is this solid conductor. What is the disadvantage means? So much area of the conductor is not utilized. This entire area inside, so that material we are not using. Whenever that material not using, will there be any use of this material? There is no use, right? Now you see, because of the skin effect, all the current will be concentrated near to the surface of the conductor. Got it, right? So that means whatever inner area, it is of no use. There is no current flow inside. That means we are not utilizing this material properly. Why to give that much big material? Whenever you are using this material, weight of the conductor it will be more, right? Whenever weight of the conductor is more, then what you have to do? So definitely, so there will be some unnecessary use of this material. You got it, right? So as skin effect is more, okay, so you understand, skin effect is more, okay, so we can call as, instead of telling like material is wasted here, we will understand like skin effect is more, okay, so skin effect is more in solid conductor system. That's why instead of using solid conductor system, we will go for other types of conductors, okay. So I will tell you why some other type, okay. So instead of this much big material, so instead of this much big conductor, if we have a smaller conductor like this, okay, so then here also some skin effect will be there, but not much, okay. So very less area will be wasted here, okay. So that's why instead of big conductor we have to use small conductor. Got it, right? Solid conductor only. If you use big conductor, so more material will be wasted. So that's why what you have to do, you have to use smaller conductor, okay. So if you have any doubt, sir, voltage step up transformer, power step up, yeah, So there are, see, if you ask me what is the after generation, okay, I will give you clear cut idea, okay. So for example, we have thermal power plant or hydroelectric power plant, okay. 11 kV voltage generation will be there. Directly 11 kV will not be transmitted, right? So we will step up that voltage to 400 kV, where you can connect to a power grid. Okay, so power grid voltage is 400 kV, so we will be stepping up that voltage immediately after the generation. We will step up the voltage to 400 kV. After 400 kV, now the transmission starts from here. This is secondary transmission. Generally, primary transmission means immediately after the generation. Okay, so immediately after the generation, 11 kV to 400 kV. Okay, that is primary transmission. Then secondary transmission means, so we need to decrease the voltage levels. Okay, why we need to decrease the voltage level? Why we have to increase the voltage level first? I will tell you one more point here. You see, whenever power equal to, okay, so generally power equal to voltage into current you will take. Okay, so high current transmission or high voltage transmission, two types possible. If you want to transfer more power, for example, if you want to transfer from the sending end to the receiving end more power, voltage may be more or current may be more, any one you can prefer. For example, you see, so resistance formula, according to Ohm's law, what is the resistance formula? R equal to V by I. That means R is inversely proportional to I, we can get. Okay, so R is inversely proportional to I if the voltage is same. Understood, right? Now resistance formula, if you see, rho L divided by A it is. Okay, so rho into L divided by A is proportional to 1 by I. During the design stage only this is. Okay, so resistivity of conductor it is same. We are using aluminum conductors, so we are not preferring any other material, so resistivity is same. And similarly, length of the conductor between the load center and generating center, length will not be changing anything, right? So length is also constant. So area of cross section of the conductor is proportional to current flow in that. That means during the design, before we design the transmission line, if more current has to flow in that, then we have to choose the conductor with more area of cross section. Got it, right? That means what we will do is, instead of doing high current transmission, we will not prefer high current transmission, we will prefer high voltage transmission. Whenever you prefer high voltage transmission, current will be less, because through the transmission lines high power has to transfer at a time. Okay, instead of that, if less power we are transmitting, we cannot reach the load centers in time. Okay, so that much power required at the load centers, so you may not reach that much of demand. That's why more power has to be transferred through the transmission lines. If your current will be more, then area of cross section of the conductor it will be more. Whenever area of cross section of the conductor is more, then automatically so material wasting will be more. That's why high voltage transmission you will prefer. Got it, right? Why we are stepping up the voltage to 400 kV? Because high voltage transmission we are getting some advantage. What's that? Conductor size will decrease, I will be decreasing, right? Current will be decreasing. Whenever current decreases, area of cross section of the conductor decreases, material requirement will be decreased. You got it, right? Now you see, this much of material we are using actually for some current flow in that. Now whatever we are using here, okay, so we have understood, instead of using big conductor, we have to use small conductor. But how it is possible? If you use small conductor, power flow will automatically decrease. Anyway, we are increasing the voltage, so high power transmission is possible, but whatever already current flowing in that will be decreased here, right? So that's why instead of using one single small conductor, we will use many smaller conductors. Got it, right? From the big conductor to small conductor, why we are using? In this big solid conductor, skin effect is more. That's why we are using smaller conductors. Okay, so whenever you use small conductor, current rating will be decreased because area of cross section is directly proportional to I. Got it right? That means whenever area of cross section is less here, current we cannot make more here, okay? Through this conductor, more current flow is not possible. That's why what we have to do, we have to take many conductors of smaller size like this, okay? To meet this much of current. Understood, right? To meet this much of current, you have to take many smaller conductors, okay? So power increase cheyalemu asalu. Power increase cheyochu, there is no problem, okay? But if the transmission line is designed for 200 megawatt of power flow, for example, okay? So just active power flow. But suddenly if you increase the power, the transmission line cannot balance that. Stability will be lost. That's why during the design stage only, what is the maximum current flow in that? Like that, we have to design. That depends upon the area of the conductor. Okay, area of cross section of conductor. There is some other possibility also. Now, for example, 200 kVA of 200 kVA of apparent power, it is just transmitting through the transmission line, for example. But suddenly at the load side you need 400 kVA for example, okay? 400 you need. So what you will do is, we can make it as a parallel circuit lines, okay? So double circuit lines we can make. Otherwise we can convert into some advantages, some other ways are there where you can improve the power transmission ability. Okay, that means steady state stability limit we can increase by converting as bundle conductor system. Okay, so that I will discuss later. Okay, we have bundle conductor systems also, so in that points we will be knowing about that clearly. Okay, so power transmission, so through the transmission lines, okay, so we can know this formula, P equal to P max sin delta. Okay, so if you send more power, then delta will increase. Delta is nothing but rotor angle. When delta will be increasing, stability will be decreasing. Understood, right? That's why, however you have designed normally, so that designed thing, okay, so up to that level only you have to transmit the power. Suddenly if you send more current through that means more power transfer through that, transmission line will lose the stability. Not only transmission line, whatever the generator, okay, so it's also losing the stability. Okay, so that's how you can understand. You got it right? You understood this point? Now you see, instead of using big conductor, we have to use the smaller conductors. But can you make this many conductors like this? First conductor, second conductor, third conductor, fourth conductor? We will not make like this. Okay, so that's why instead of using solid conductor system, we are going for the stranded conductor system. I have given the reason, you can observe on screen. Okay, so I have given the reason why we are going for the stranded conductor system. That means, so whatever, to reduce the skin effect, a number of single strands are taken and twisted together throughout the length such that conductor cross section is circular. Okay, so we understood. Okay, so we cannot make like 10 conductors, 10 smaller conductors, 1 2 3 4 5, like if you take more area we need, right? Okay, and otherwise whatever transmission pole will be there, cross arm will be like this, first conductor, second conductor here, third conductor. It's not a good model, right? Okay, that's why we have to take smaller conductors. Okay, so to reduce the skin effect, this is the reason. Okay, we are going for the stranded conductor. Okay, how we are making the stranded conductor means like this. Okay, so let's understand. There will be smaller strands we are using, all of same size. Okay, all, how many we are giving here? All are having same size. You got it right? So generally 7 will be there, 7 strands will be there, one inner strand. So but these are materials. What is the material we are using? What is the material we are using? So this material is same aluminum only. Material is not changing, but type we are just changing. Okay, so material is aluminum conductor. Okay, so this is aluminum, this is aluminum, inner one is aluminum. Okay, so either all other ones also aluminum only. What is this type of conductor means? So this is all aluminum conductor. Okay, so all aluminum conductor. Okay, so why we are using like this? Because if you use a single big conductor, skin effect will be more, okay? That's why we are using like this, okay? To reduce the skin effect, instead of solid conductors, we are using a stranded conductor system. Got it right, the point? And one more thing I have just mentioned here, okay? So many strands, single strands have been taken and twisted together, okay? So twisted together means why we have to twist this? So why we have to twist? Now you see, whenever many conductors are like this, okay? So then so they will be loosely coupled, right? Between these things, loose coupling will be there. So whenever wind will be coming with more high wind velocity, then automatically this will be moving like that, okay? So it is a stable system we want, okay? So mechanically a stable system we want. That's why this many strands we will be taking and we will twist like this, okay? Between the two poles, okay? If you have two poles, during the installation process, okay, connect here and twist together like this all these conductors and connect to the other side. Got it right? Whenever you are twisting like that, you may get this point, okay? So whenever directly if you are using here, okay, directly if you are using here, then length will be something. If you twist, length will definitely decrease, right? Okay, understand one point. Whenever stranded conductors we are using, length will be decreased between these two poles. If you use single conductor, some length will come, okay, it will be sufficient. But if you twist like this, then length will be decreased, right? You can understand that point, okay? So anyway, ఇన్నర్ సైడ్ స్టీల్ కండక్టర్ కదా సార్, స్టీల్ కండక్టర్ ఇక్కడ మనం యూజ్ చేయట్లేదు, అది కాంపోజిట్ స్టాండర్డ్ కండక్టర్. ఒకే టైప్ ఆఫ్ మెటీరియల్ మనం యూజ్ చేస్తున్నామంటే అది స్టాండర్డ్ కండక్టర్, ఓకే? ఆల్ అల్యూమినియం కండక్టర్. దట్స్ వై ఐ టోల్డ్ యూ, ఓకే? ACSR వీఆర్ యూజింగ్, దట్ ఈస్ aluminum conductor with steel reinforcement, okay? So we don't know how we will understand inside we have to use the steel. First we will see, okay, whenever you have aluminum, what is the problem with this conductor inside, what is the difficulties we are having with standard conductor system, then only we can make into the steel that. Got it right? So directly answer we know for this type of bits, okay? So instead of AAC we are using ACSR type of conductor. You got it right? ACSR only we are using. ACSR means aluminum conductors with steel reinforcement. So that is inner one is steel only, that is the correct one, but not for these conductors. We are not using these conductors. These are all the bits. Why we are not using stranded conductor system? So we may know the bit, okay? So inside inner one we are using as steel, we can understand that point, but why we are not using that? You got it right? Why only steel we are using? Why we are not using aluminum conductor inside? These are all the bits, okay? Even in the interviews also they will be asking this model of questions, okay? So and understand one thing, whenever we are studying power systems or machine subjects, okay, or measurement subjects, so the order is so important, okay? So never miss a single point, so then you cannot go back again, okay? So if you go back, you will not understand properly. So at that time only, first time only, if you read so complete analysis, you have to make like that, okay? So inside I will only tell you after some time why we are using the steel, okay? After 2 or 3 points, okay? So one more thing, transformer is a constant power device. Power is the same, but voltage and current changes depends upon the step up and step down. Yes, it is true, okay? There is no problem. For the transformer it will be, okay? But transmission lines, whatever we are using here, we have to design the size of this one, size of the conductor, we have to decide that. Then only we can make the power transfer. Otherwise, how much power you want, that much you cannot send. So just based on the area of cross section of this conductor, we have to make that, okay? So that's what important for us. You understood, right? Okay, if you have any doubts, you can ask me in between also. There is no problem at all, okay? So anyway, all aluminum conductors, whenever you use like this model of conductor, standard conductor, whenever you twist between two poles, length definitely, whatever material we are using, it's not sufficient. So you may understand, for your sisters or mother, we will be having this long jada we will call, right? Okay, so whenever they do this, length will be decreased. Whenever they release that, then length will be little bit more. Why that is? Whenever we twist like that, length will be little bit decreased, right? Got my point? Similarly, between these two poles, whenever you twist like this transmission line conductors, it is not sufficient up to the next pole. So what happens? Some extra material required. You got my point, right? So whenever you use standard conductors, material requirement is more, okay? So otherwise more material required, okay? So more material required, this point, okay? So whenever more material required, little bit cost will be more for the standard conductors. Understood, right? And you may think there will be some insulation also between these all. So there will be some paper insulation or impregnated paper will be having, okay? So just to make contactless between these all, okay? So some impregnated paper also will be there. Understood, right? So and one more thing, whenever this many smaller things are there, is there any bonding between these all? Like solid conductor, if we have a solid big conductor like this and stranded conductor, okay? So this is solid conductor system and this is stranded, okay? So this is stranded. When you compare these two, which will be stronger means, you can understand solid is more stronger when compared to stranded conductor. You may think like whenever many sticks are like this, then it will be more strong. Don't think like that. These are smaller conductors. This is one big conductor. You got it right. Whenever one big conductor is there, it is more stronger, and that's why whenever we are using like this many smaller conductors, loose coupling will be there between these all. Even though after twisting also loose coupling will be there. And one more thing, material requirement is more, we have written, so sag will be more, okay? So let's compare these all, okay? So how the sag will be more in this between two poles. I am just mentioning different type of conductors, okay? So this is the actual path, okay? This dotted line is nothing but actual path which is straight, okay? If you take the solid conductor system, okay, if you take the solid conductor system, it will be almost near to this, okay? So like this, almost near to this, okay? So this is nothing but solid conductor system. But if you take stranded conductor system, for stranded conductor system, so it will be little bit more sag. You got it right? So this is stranded conductor system, okay? So whenever stranded conductors are there, the sag increases. You can see this is the actual path. The dotted line is nothing but actual path we have. And whenever we have this stranded conductor system, okay, so material requirement is more, and similarly, so there will not be any strong bonding between these all. That's why we can mention as, so there less mechanical strength, okay? So less mechanical and tensile strength we can write down, okay? So less mechanical and tensile strength. Whenever like this, then definitely sag increases, okay? Sag means, so it is the path which is forming below that actual path, okay? So this is nothing but the sag area, okay? So this is nothing but sag area we have. So whenever you take stranded conductor system, sag increases, okay? So compared to what? Compared to our solid conductor system, sag increases for this, okay? So understood, right? So if you have, hello everyone, okay? So if you have any doubt, you can just ask me. There is no problem, okay? So there are some more points also. If you have any doubts in this in deep, you can ask me. There is no problem. And you see, as the sag is more for AAC conductor, this is all aluminum conductors, okay? As sag will be more for this, we have to improve this mechanical strength and tensile strength. To make that, what we are doing is, instead of using this type of strands, we will be using different strands, okay? So different strand means, you can observe the same type of smaller conductors we are using, okay? Same type of smaller conductors only we are using, but whatever we have already discussed some time before, okay? So that is nothing but, so you see, inside one, we will be using high strength material. High strength material we will be using inside, okay? So I will tell you what material we can use. So you may know already this point, okay? So what material we are using inside to increase the strength? To increase the strength of this entire conductor, what is the material we are using inside? That's what steel, right? Steel has good tensile and mechanical strength, okay? So that's why all outer sides, okay, outer side whatever we have, so these are all our aluminum conductors, okay? So these are all aluminum conductor, okay? So aluminum conductor, but whatever inside we have, that is nothing but steel conductor, okay? This is nothing but steel, okay? You can see the statement whatever I have given. To increase the mechanical strength and to decrease the sag in AAC conductors, composite standard conductors are used, okay? Composite standard conductor means more than one type of material we have to use, that's it. More than one type. If you want, you can use more different type of conductors. One is aluminum conductor, one is copper conductor, like that we can use, but there is no use, okay? The conducting path must have good conductivity and it should be economical for us. Sag has to be less, our skin effect has to be less, and corona loss has to be less. These all things will be there, okay? So that's why inner one, whatever inside one, middle one, we are using steel conductor. Now you see, what is this type of conductor? ACSR type of conductors, okay? So I told you at the beginning, so directly we are not using ACSR type of conductor, okay? So the question is, in hydroelectric plant, why 4 bays are used? So I will tell you this point, okay? So why 4 bay will be used, I will tell you. See this, for example, dam constructed, okay? For example, dam constructed, but certain head is not formed. Head means, so water flow will be there from certain head, right? Okay, that is not formed because generally for hydroelectric power plant, what is the perfect place to locate? That means, so between two hills, whenever river flow will be there, between two hills, that is the exact place, okay? You can directly construct a dam, you can stop the water in the reservoir, and from that head you can take that water. So that is the actual idea, right? But in some places, so there may not be possibility of any hills, okay? So whenever there are no hills, so there is no certain head possibility. So what we have to do is, wherever you have constructed the dam, wherever you have stopped the water, so from there to the other side, wherever some hilly area is there, okay? Wherever some hilly area is there, you have to take the water to certain height, okay? And from there you will take into the turbines. Understood, right? Whatever link we have provided from the actual dam to the other side, to the powerhouse, okay? So we have taken some other line like this, right? Okay, otherwise you see, if this is the dam, okay, where head is not possible, okay? So this is the dam where head is not possible. So what we will do is, from here we will take one pipe, okay? So this is not small pipe, okay? Just RCC pipes these are, okay? Concrete pipes these are. So we will take into some other place, certain head we will provide, and from there we will take the water into the buckets of this turbine. Got it, right? So this pipe is nothing but 4 bay. Okay, so this is nothing but 4 bay. You understood, right, this point? So in hydroelectric power plants, if head is not possible, then we have to create the head by using some external pipe. That external pipe is nothing but 4 bay. In general, there will be penstock directly like this, okay? So this is, so tunnel actually. So this is a tunnel. After that penstock will be there, okay? So this is penstock. Okay, so directly these things will be there, but whenever you use 4 bay, so that is not this path, that is external path. From other path we are just coming to increase the head of that power plant, okay? So that's why we are using 4 bay. Is it clear? Is it clear? Surge tank will be there. Surge tank is must, okay? Whenever surge tank is there, then only water hammering effect will be present, okay? Water hammering effect we can avoid, okay? So for example, if load increased, according to that water flow has to increase, right? Okay, so let me give that point again. So I will come to this point, okay? So within 1 or 2 minutes, okay? So for example, this is the penstock, okay? So penstock, at the end of penstock we will be having the, so this is nozzle, okay? So this is nozzle, this is penstock, okay? So whenever, so turbine will be here, and let's take this is Pelton wheel type of turbine where we have the buckets here, okay? So these are the buckets. Water flow will be hitting on these buckets like this, Got it right? Whenever water flow will be there, so turbine will rotate because of the pressure it will create. So using the same shaft, the generator rotor will rotate, synchronous generator basically, and that will give the power generation. Okay, that part I am not explaining, this one we will take. Okay, whenever more power requirement, more water has to come. Understood right? More output has to be coming. Output has to come means more input flow, that means more water flow has to be come. But you see, where is the dam? Dam will be around 1 kilometer away from this power station. Okay, so from this powerhouse we will be calling. Okay, wherever generator, turbine and this nozzle will be there, so these are nothing but our powerhouse. Okay, so from the powerhouse, our whatever dam will be, it is around half kilometer or 1 kilometer. From that distance, water if it come here, it will take certain time, but immediately if you want, whenever load is changing, we have to change the water supply here. So what you will be giving means, you will give some surge tank here. Okay, we will give some surge tank here. So generally surge tank will be so having some water, external water. So whenever more water requirement will be there, this water will be decreased. Whenever for example load decreased means, previously for example 200 megawatt, now it is only 100 megawatt. That means more water should not go, water has to go back. Will it go back to the dam again? During with that much force water is coming like that, can all water can go back like that? It's not possible. Because of that, there will be external pressure on this one. Okay, some negative pressure will be created in this penstock, so penstock may break down like this. This effect is nothing but water hammering effect. According to the load changes, according to the electrical load changes, water flow must be controlled. How water flow will be controlled? So there will be speed governor system. This nozzle width will be increased or decreased according to the water flow requirement. Got it right? Whenever water flow will be changed according to that, so there will be pressure creation. Okay, so sometimes positive pressure, sometimes negative pressure will be created. If more water is required, this water will come down. If extra water is there, that water cannot go to the dam again. So this water level will be increased like that. Okay, so that means this is saving the penstock. Okay, so this is nothing but our saving system for this entire power plant. Otherwise, because of the water hammering effect, this pressure on this penstock will be increased and it will be broken like this. You understood right? So this is the point. Okay, that's why surge tank must be present, and that too if it is very far from this powerhouse, again it will be damaged. Okay, so that's why this whatever surge tank. Okay, so this is nothing but surge tank. So this surge tank has to be near to the powerhouse, then only our penstock will be safe. That's how you can understand. Is it clear? Just answer. Is it clear? Whatever your doubt about the surge tank and we have this. Okay, so another one, 4 bay we have understood. Okay, so is it clear about that? Yeah, it's okay. Okay, so now whatever we have, ACSR type of conductor we have understood. So what is the advantage? Whenever you use the steel conductor, the strength, mechanical strength and tensile strength between the poles, okay, so it will be increased if it is the actual path between that poles. And I will give you all the 3 type. Okay, so if this is the solid conductor system, okay, so blue one is nothing but solid conductor system, and I will take the stranded conductor system. Okay, so AAC we will take. Okay, so this is AAC type of conductor, and whenever you use ACSR type of conductor, okay, so this is ACSR type of conductor. Okay, so now we have compromised some of the sag. For solid conductor system is more strong it will be. That's why we will be using solid conductor system whenever it's required. But ACSR is preferred one, because in solid conductor system more material will be wasted, because skin effect will be more in that. Okay, so that's why we should not use this solid conductor system because of the skin effect. We should not use all aluminum type of conductors. Why? Because in AEC conductor sag will be more. Okay, you can understand, sag will be more. That's why ACSR type of conductors we are using. ACSR means aluminum conductors with steel reinforcement. Okay, so like that we have to use. And you see, but is this surface smooth? Is this surface smooth? When you compare with solid conductor system, so this is smooth surface. Okay, so this is smooth surface. So when you compare, okay, so when you compare our stranded conductor or composite stranded conductor, okay, so stranded or composite stranded conductor, surface is that smooth or rough? It is rough surface when you compare with this. That means whenever you use composite stranded conductor, which loss will be increased? Surface is not smoother, so definitely electrical current loss will be increased in this one. You got it right? Voltage stress on the conductor, it will be little bit more when compared to solid conductor system. Okay, so these are some of the other points you will be having. Okay, so that's how you need to understand. Okay, so I told you why we are studying, why we have to use this ACSR type of conductors. Okay, we are using ACSR type of conductors because stranded conductors having some problem of sag. Okay, so and similarly whenever we are using solid conductor system, then we are getting more skin effect. That's why we are using ACSR type of conductors. Any voltage system, it is 400 kV. After 400 kV we have 220 kV. After that 138 kV we have. After that, if possible, there is 90 kV. So there are some loads which work with 90 kV also. 66 kV, 33 kV. After that 11 kV. Up to that, these are all transmission voltages. Later in the distribution, we have single phase distribution and three phase distribution. Okay, so this is about why we are using ACSR type of conductors. Okay, you can ask me some doubts if you have anything. Okay, so in any power system, but in 5 minutes I will give you clear idea about power system. So how you need to prepare. Okay, whenever you prepare power system, first you start with generation concepts. Okay, so complete the major types of generations are three. Those are hydroelectric power generation, second one is thermal power generation, and third one is our nuclear power generation. There will be definitely some bits in nuclear power generation every time. Okay, so in every exam, that too, okay, you go for GATE engineering services, there will be some possibility of question. Okay, so may not be in GATE because in GATE they will be giving some problematic questions. Okay, so that's why you may not expect directly every year, but there may be possibility. Okay, but in every SSC junior engineer exam at least, or RRB junior engineer exam of electrical, or we have any PSU you take, okay, or any state level exam. In Telugu states we have Genco, Transco, like these exams, right? Okay, in these also generation concepts are so important. Okay, so don't leave, and those are so simple only. Okay, only once you have to read all those things, that's enough to get. Okay, so that's how you need to prepare the generation part. Okay, later you start the transmission and distribution, all the things. Okay, so whenever you are studying the power system from the beginning to the end, okay, so don't leave a single concept, you study like some story. Okay, so however we have just made solid conductor system, we are using stranded conductor system. Why? There is some reason. Why we are using composite stranded conductor system? There is some reason. Like that, we have bundled conductor system also. We have hollow conductor system also. Okay, but we are using ACSR. So those applications are different. Okay, so in some other sessions we will be understanding about those things. Okay, so that's it for. And after transmission and distribution, you start the analysis part. Okay, where you will be knowing about, so analysis of transmission line, like per unit system we need to study. Later fault analysis we have to study. Stability analysis, where rotor angular stability, swing curves, equal area criteria, these all concepts. Okay, so after that Z bus and Y bus analysis we need to know. So after that economic load dispatch you have to study. Economic load dispatch means whenever there are more number of power stations who can give the power supply for us, what has to give how much power. Like this power station has to give 50 megawatt, this power station has to give 20 megawatt. Like that we have to economically give the economic power generation we have to make. Okay, so like these all concepts you need to understand later. Okay, after that protection concepts also you need to know. Okay, so these are all the things. Okay, in this order if you just learn, then there is no possibility that you will lose some concepts. Okay, so definitely, so there are some difficult concepts. Okay, but understand one by one. If you study, then only we can we remember the power system concepts. Okay, so in this order: generation, transmission, distribution, power system analysis, after that economic load dispatch, after that we have our power system protection. Okay, so this in this order we have to study. Okay, understood, right? So that's what. So anyway, if you have any doubts you can ask me now. Okay, if you have any doubts in power systems or any preparation, if you have anything, then I will be giving those. Okay, so and myself, I am Vishnu. I am teaching electrical networks, electrical power systems and measurements from past 6 years in various institutions. Okay, and I have previously worked in some companies also, but now I am completely in teaching only. So if I have some experience about the exams also. So if you have any doubts in that, otherwise guidance, anything, you can ask me. So I will be explaining you those. Okay, but remember the concepts like power systems, in power system concepts, and similarly machines concepts and measurement concepts. Okay, only once you have to prepare properly, then every exam. And remember, there is no difficulty. If you feel difficulty, then it is difficult. Otherwise there is nothing like difficult in power system. Okay, you have to practice only once, and whenever you are practicing, you write something. Okay, so write and so do the practice, then you will never forget those all. Okay, my suggestion. And so types of hydroelectric power plants based on type of location. Okay, so there are two types actually. Okay, so two types of hydroelectric power stations we have. So one is, I will tell you clear idea once. So there are two types of rivers. You take Ganga river is there. Okay, Ganga river continuously flows throughout the year. So is there any requirement to stop the water? Is there any requirement to construct the dam? There is no need to construct the dam there, right? Big dam is not required. Small dam, like in our states we'll be seeing like check dams. Okay, so like check dams are enough. That means more head possibility is not there. Got it, right? No need to stop the water. Continuously water flow is there. If you stop that, definitely that will cause some problems in that area. Got it, right? And one more river I will tell you. We have, so Godavari river or Krishna river you take. The entire river you will not get the water flow. That means whenever flood season is there, during the rainy season, whenever water flow is about to stop, we will stop that water. We will store that water. And whenever you require power supply, at that time only you will be using. Got it, right? Now you see, for entire day, for example, I need every day in a year, I need 100 megawatt for my application. Okay, some loads I have. For my loads, I need 100 megawatt daily, for example. Okay, so that means daily which power plant can be run? So the power plant on Ganga river or power plant in this Krishna river, what you can just make? So power plant on Ganga river only, wherever water availability is more, wherever continuously throughout the year water flow will be there. Got it, right? That means that type of power plant, that is nothing but base load power plant. Got it, right? So if continuity of water is there, if ample amount of water is there, if more amount of water throughout the year is present, then no need to construct a big dam. Okay, small dam is enough. Okay, that means runoff river without pondage. Okay, so runoff river without pondage, this is first classification. If water availability is not there, you have to construct the dam, you have to choose proper place, and you have to create some head, then only whenever peak load is there, that means a sudden load increment. For my applications 100 megawatt only required, for example, but one day I want to operate some extra machines, for example maybe 1 or 2 days. At that time I will be using so hydroelectric power plant, wherever you have stored the water, that water we will be using to increase the power supply. You got it right? There are actually only 2 types of power plants: run off river without pondage. Without pondage means like in Ganga river, so there is no need of much head, okay, no need to stop the water. Second one is run off river with pondage. You have to construct the dam. Pondage means dam, okay. So run off river without pondage, run off river with pondage. And even worst case, so throughout the year only like 1 month only water availability will be there. So there are third type of power plant we can make, that is pumped storage plant, okay. So pumped storage plant means whatever we have to stop the water, just like in Krishna river, okay, we have to stop the water. So water will be used during the peak load period, okay, and that water we will not send to the downside, we will send back that water again into the main pond, okay. So from the tail pond means after the generation we will release the water to the downside of the river, right? Now we will not release this water. Why? We will store that water at the other pond, which is called tail pond. From here to the main pond we will be sending back, okay. So this is pumped storage plant, okay. So there are 3 types, but basically there are only 2 types. One is run off river with pondage, run off river without pondage. And whenever pondage is there, whenever dam is there, we can make that one as our pumped storage plant also, okay. Like 3 classifications we have based on their water availability, okay. So like that. Yeah, is it clear? You can even ask, okay, so any preparation strategies or anything if you have any doubts, okay. So that's better. సో ట్రాన్స్కోజన్ కు సిలబస్ చెప్పండి. సిలబస్ మనకి యాక్చువల్గా అయితే ఏ ఇయర్కైనా కూడా సేమ్ సిలబస్ ఉంటుంది, ఓకే. మన పవర్ సిస్టంలో ఇప్పుడు తీసుకుంటే నేనైతే ఏవైతే చెప్పానో ఆర్డర్లో చెప్పాను చూసారా, సో సేమ్ సిలబస్ ఉంటుంది. జనరేషన్ కాన్సెప్ట్స్, ట్రాన్స్మిషన్ అండ్ డిస్ట్రిబ్యూషన్, పవర్ సిస్టమ్ అనాలిసిస్ అండ్ ఎకనామిక్ లోడ్ డిస్పాచ్, పవర్ సిస్టమ్ ప్రొటెక్షన్, ఓకే. సో అప్ టు హియర్ ఓన్లీ. అండ్ యాక్చువల్గా కొంచెం సిలబస్ అప్పుడప్పుడు చేంజ్ అవుతూ ఉంటుంది, ఎందుకంటే కొన్ని కాన్సెప్ట్స్ తీసేస్తారు మళ్ళీ యాడ్ చేస్తుంటారు అనమాట. ఆ ఇయర్ సిలబస్ వచ్చిన తర్వాత మాత్రమే మీరు కంపల్సరీగా ఉందో లేదో చూసుకోండి. అదర్వైజ్ ఆల్ ది సిలబస్ 1 or 2 టాపిక్స్ ఓన్లీ వాళ్ళు తీయచ్చు, లేకపోతే యాడ్ చేయొచ్చు ఏదైనా కూడా. సో నో నీడ్ టు వరీ. ప్రీవియస్ సిలబస్ ఏదైతే అవైలబుల్గా ఉందో సో దాన్ని మీరు ఫాలో అయిపోవచ్చు, దెర్ ఈజ్ నో ప్రాబ్లం, ఓకే. Yeah, thank you so much everyone.